Alright, first video on this iPad. Let's do it. Okay, so this question, actually, let me preface this first. So these videos are for a specific person, but they might end up on my YouTube video, on my YouTube channel, so we will see. But what I want you to get out of this is to be able to look at a problem, look at like the beginning of the problem and look at the end of the problem and kind of be able to visualize what you want to do to get from the beginning to the end. You won't always be able to do that, but hopefully this will help you like start to see where you're supposed to go with problems like these. And what I want you to do is every time like I do some kind of step, think about why I did that step. I'll try to emphasize it, but think about why I might have done that, and like think about what you might be able to do next before I continue. Because if you just like mindlessly watch what I'm doing, what might end up happening is you'll kind of consume the information, but you won't really be able to like utilize it in different variations of this like information needing to be used. Because math team is a lot about problem solving, and half the battle is knowing the stuff and the other half is knowing how to apply the stuff. And I think you know the stuff and you just need help with problem solving. So let's get into it. A particular conic section is the set of all points equidistant from the point 12, 4 and the line x equals 4. What is the x value of the point on this conic where y equals 20? Now to start off, what is this conic section? What is this conic section? It's the set of all points equidistant from like one point and the line x equals 4. If we quickly draw out a general example of that, you got a line and a point. The conic section that you'd be graphing out would be something like this. So that would be your first point where these are equal. Then your next one that might look like that, where those are equal. And then like that. Obviously this isn't like drawn the best, but it's gonna look like that. Oh god, that bonk. Yeah, obviously not the best, but you'll see that this actually draws out a parabola. And I'm sure you know this, but the reason this is important is because there are two things that you can get out of this. Number one, the point that everything stems off of is the focus, and and the line that everything connects to vertically is the directrix. I believe that's how it's called. So that's your terminology. The distance between the focus right here, let me switch to red. Distance between the focus and the vertex, and then the vertex and the directrix, because those are equal, we commonly refer to that as P. So there's one P right there and there's one P right there. And that'll come useful for the equation that I'm about to go over. And it goes for a normal quadratic where like it's curving upwards, you'll have the equation let's start with that. X minus h squared equals 4p y minus k. Now, as you know, h is the x, no, like the x term for the vertex, and k is the y term for the vertex. P, as I just mentioned before, is this distance from the foci to the vertex, and also the vertex to the directrix, which you can find easily because you know that the directrix and in this specific example, you know the distance between the directrix and the focus, which means all you have to do is find that distance. And because there are two p's in here, this is 2p, which means p is 1/2 that distance. So that's how you find p. And the way you find h and k is pretty much the same thing. You take the For one of the values, it depends. Like if it's a vertical graph, it might. Oh my god, why is it not? What? It's not drawing anything. Hello. What the hell? Okay, what is going on? Technical issues. What just happened? What? Okay, we're back. We're back, guys. We're back. That's my bad. My bad. I actually have no clue what happened, but my bad. Damn. Where was I? Oh yeah, to find h and k, all you have to do is to take the focus is going to be certain distance away from directrix, and you can tell which direction the parabola is facing based on that. In this example, the thing I have drawn out here, the focus is a certain y distance away from the directrix. That's not actually true for the equation, but it is true for this, which means that the y variable between the focus and this line will have to be averaged to find this, to find the y variable of this. And the x variable doesn't change for this and for where it touches here. So the vertex is going to have the same x variable as the focus. For an example like this, those two switch if it looks like this, where now you take the average of the x values, because those are equidistant, even though it doesn't look like that, and the y variable is what stays the same. So that's how you find those. Now I'm going to erase that. You can always go back and rewatch that if necessary, but now I'm going to use, actually, let me not erase that so I can go reference it. Let me just move it down. Bonk.